So example number 1, the square root of 72a to the 5th power. So when we start simplifying the square root with variables, we're going to start by first simplifying the numbers. Okay? So what that means is we're going to go ahead and factor 72. That's what we know. So what two numbers can I multiply together to get 72?
89.
Okay? And then for 8,
2 and 4.
and then 4,
Oh, 2, 2.
and then for 9 is 3 and 3. So we're going to go ahead and factor our number in the same manner that we have in the past. And we're going to come up to the right of the square root, and we're going to put our equal sign, we're going to put our square root sign, and we're going to put all of our prime numbers in order from least to greatest. So this is all new or old stuff, right? We've done this. There's nothing new here. Now, after I do that, I now need to go ahead and factor in my variable. A to the 5th power means I have how many a's there? 5. So guess what I'm going to do? I'm going to write that a out how many times? I will show you a shortcut in a moment, but I want to do it this way first. 5. Okay, so there's a little bit of the new stuff. Now we go back to our old stuff. What do I do with my factor pairs?
Circle the pair.
So I'm going to do the exact same thing here. So I have a pair of 2's I'm going to circle. A pair of 3's I'm going to circle. I have a pair of A's I'm going to circle. And another pair of A's that I'm going to circle. What happens to my factor pairs? Yeah, they cancel with the square root sign, and where do they go?
To the outside of the coefficient.
Yeah, to the outside is the coefficient. So my 2 is going to cancel my 3, an A, and an A. So when I go to rewrite this here, I'm going to put my equal sign. So what's my number? What's my number going to be? 2 times 3 is 6. Now, how many A's did I cancel out? So how many A's am I going to have on the outside? So A
To the 2nd power.
or A squared. And then I'm going to have my square root sign. Then what's my radican? What do I have left on the inside there?
2 A's.
2A. That's it. Now that's really not it. You guys know I'm going to make it harder, right?
What?
But this is the groundwork. This is the building block. We're going to build upon it now.
We can't build upon that quick. Just like today.
You'll get it. I have faith in you. I think you guys are a pretty intelligent group. All right. Does everybody have this down? Okay, let's take a look at example number 2 then. Now, the only difference between example 1 and example 2 is that now you have 2 variables. Okay? So we're going to follow the exact same steps of what we just did. So the first thing I'm going to do here is factor my 50. So Deontay,
5 and 10, then 2 and 5.
give me a second. 5 and 10. And then for 10,
2 and 5. And then circle your
circle my prime numbers.
and draw the square root, and then
Let's draw my equal sign first.
equal sign, then draw the square root.
This square root sign is going to have to be extra long, right?
Then put your stuff from least to greatest.
So 2 times 5 times 5.
Times 5.
Now, how many times am I going to have to write my B out?
4.
How many times am I going to have to write my C out? So write small. So I'm going to write my B out 4 times. I'll show you a shortcut.
That's square root.
Okay. We all have it?
Yeah.
So then you go ahead and circle all your factor pairs. I'm going to use a different color there.
How are we gonna fit all this inside of a coefficient?
Easy. Okay, so now that I have my factor pairs circled, I can go ahead and cancel them out with the square root sign. And then I can go ahead and determine what my new coefficient is going to be. So what number moves to the outside as a coefficient? The 5. Now, my variable b has how many pairs? So it's going to be b to the what power?
2.
To the second power. And then I have a c. How many pairs of c's do I have?
5.
So c to the 5th power. Square root sign. Now what do I have left on the inside?
2.
A 2c. And that's it. Now, that's a lot of work, right? Sitting there writing that c out 11 times, it's a little ridiculous. It's not very time efficient. I'm going to show you a shortcut, okay? So when I go to show you the shortcut, I would prefer you to do the shortcut rather than writing these variables out however many times it's listed up there. So what we're going to do, we're still going to follow the step where we factor our number. So we're still going to follow that step. So I'm going to show you the shortcut here in blue. So we're still going to factor it out. We're still going to put our equal sign, our square root, and we're going to put our prime numbers under there. 2 times 5 times 5. Now we're going to bring down our variables, b to the 4th power times c to the 11th power. We're just going to write it as that. I'm going to circle my factor pairs. My factor pair is still going to go to the outside. So what still moves to the outside? The 5. Now, this is the shortcut. It takes a pair to cancel with the square root sign, right? Pair means 2. So what you're going to do is you're going to think, how many 2's can go into 4? So what's 4 divided by 2? Does it work out evenly?
Yeah.
Yes. So if 4 divided by 2 is 2, your outside is going to be b to the 2nd power. So that basically cancels out. You're done with that b. Okay? Now, c to the 11th. 11's an odd number, right? Are you listening? Hey, this is really important. I really need you to quit the side conversation. So 11 is considered an odd number. If you have an odd number, that means you're going to be stuck with at least one c or one variable as a Radican still. So how many times can 2 go into 11 evenly? So how many times can 2 go into 11 evenly? 2, 4, 6, 8, 10, right? How many times? 5. So on the outside, we're going to have c to the 5th. Now, how many extra are we going to have on the inside? How many are we going to have left?
1.
Just 1. What's the number that's also going to be left on the inside? 2. So do you see how we end up with the same answer? So we ended up with the same answer, just a lot less work. Now this second step is going to be a lot more mental math. Okay? This here is going to be a lot more concrete math. You can decide what works best for you, but I would recommend that you do it this way because one of our next example is going to have a variable to the 18th power. So you don't want to write that variable out 18 times. So if it is an even number, you're not going to have anything left on the Radican. If it's an odd number, you'll have 1 left in the Radican. Everything else will go to the coefficient. I know, see, you guys are all looking at me like, what is she talking about? I promise you, you will get it. All right, so let's go ahead and write our notes down. So steps for simplifying square roots of variable. It's a lot. I get it. Write it all down, though. It'll be helpful. So these are the steps that you're going to follow in order to simplify a square root with a variable. It's a lot of information. And the first time I looked at this information, the first thought, when I see a lot of this all at once, I shut down. I'm like, that's a lot. I'm not going to get it. And I just go, whoo. But after I did a couple of example problems following this stuff, it clicked. It made sense. Step one, you guys have been doing this since the beginning of the triad. You have step one down. The only thing new for you guys is basically step two. Step three we know how to do. Step four we know how to do. So the only thing new that we're doing is step two. So step two is kind of wordy. It says determine how many pairs of each variable there will be and if there will be any left over. So I want to give you an example of what that actually means. So an even exponent. So if I say an even exponent, let's say we have d to the 18th. 18 is an even number, correct? Yeah. So all we're going to do is, if it's an even exponent, we're going to have half as many pairs. So when we go to circle our pairs, well, 18 divided by 2 is what? 9. So it's going to actually equal d to the 9th on the outside. Now let's say that I have an odd exponent. So I'm going to write this underneath here in red. So let's say I had d to the 19th. 19 is considered a what type of number?
Odd number.
Odd number. So you're going to think, how many pairs can we get from 19? So how many times can 2 go into 19?
No. Wait, no.
Evenly. 9. How many am I going to have left over?
So what?
So if I put d to the 9th, that only gets me to 18, right? So I'll have how many left over?
Oh, one left over.
One left over, and that stays on the inside. Okay, and we're going to have to stop there. So do you guys all have this down? Do me a favor. We're going to stop there, but I want you guys to write example number 3 down. So flip it over. Write example number 3 down. If you get a chance in your LS class today, try to see if you can solve it. See if you can figure it out using your steps, okay?